Howdy folks, we're going to take a quick look here at how to find residuals or outlier problem data points using Jamovi. Now, when you run a regression, we're just going to use this data set here that we always use. When you run a regression, whoops, sorry about that. When you run a regression, let's say you pop variable in, pop color variables in, and you check your assumptions, you always want to make sure that your residuals are normally distributed and randomly distributed. So these look pretty good. These look pretty good. That's very random. Does this seem random to me? Not really. This could be better, but it's close enough. Sorry about that. I'm a big dummy, and that's what my texting ringtone is. So I love bike horns for some reason. Alrighty, so let's say that you noticed you had an outlier problem. There was one data point or a couple data points that were really no good. So what we could do is I'm just going to take neuroticism and I'm just going to kind of blast one of these guys. I'm going to say, well, for some reason somebody has a neuroticism score of 19. Let's make it 30. Whoa. Oh, need a lot. Okay, we'll make a couple of them. We'll make one of them 30, one of them -30. And that shouldn't change our regression line a whole lot. But now we can clearly see we got outliers here and here. If we check the assumption for Cook's distance, which is usually the assumption for outliers, probably not going to get anything too big. Usually you want a Cook's distance, a maximum Cook's distance of 1 or less. So we're still within this range of our outliers have not affected our results too much. But if I get rid of one of those two outliers, there we go. This outlier is saying, whoa, our regression line was affected a lot by this guy. Why is 2 outliers better than 1? That's because when we have this second outlier in there, the effect that this outlier has on the regression line is not as bad because it's kind of blocked out by this one here. So they kind of even themselves out. So even though you don't have an outlier that pops up in your Cook's distance, you're always going to want to check your QQ plots and your residual plots. We can very clearly see outliers throughout, and they indicate that you have maybe a problem data point or a couple problem data points. So there's a couple ways you can go about finding these. For example, if you have like something like this where clearly on one single variable the data point is really high or really low, it will be easy to find this data points. But you're not always going to get that. A lot of times you'll have outliers that are kind of in the middle of your data sets, and you won't really be able to just look for the biggest number in the variable. Remember that outliers, really what we're working with is outliers based on the regression prediction formula. So it might not be an outlier within any particular variable. It might not be that easy or simple. So how can we find outliers without them being easy to find? What we can do is, step 1, create a variable that is this regression prediction formula. So we're pretty much going to make a variable that allows us to do what this graph does down here. And we're going to do that by using the coefficients in the regression. The next step is going to be to make a variable that is the residuals, or the error between what your regression prediction formula guessed your dependent variable was and the actual dependent variable. So we're going to first create the regression prediction formula, then we're going to create a residuals thing, and then all we have to do is find the residuals that match up, that they're either really big or really small. So first, going to make a new computed variable. We're going to call this one regression prediction, And this formula is going to come from the coefficients estimates here. Remember, the formula that your regression comes up with is your intercept, so 2.913, plus the coefficients multiplied by their variables, so 0.042 times extroversion minus 0.068 times openness. So there's the full regression prediction formula. This gets a lot more complicated if you're using dummy variables. And Jamovi can't really do this automatically yet, so that's one of the things that I'm really hoping Jamovi will get that feature added. But there we go, we've got this regression prediction formula. If we double check, we can kind of say, okay, well, we have extroversion and openness. Extroversion is 4, openness is 4. So if we look at this graph down here, and we have extroversion, extroversion is around 4. So right around somewhere in this area is probably going to be our neuroticism, which is predicted anywhere, I guess that's somewhere between 2.8 and 2.85. And the regression prediction formula gave us right on the money what we guessed there. So we've made this formula correctly, and we can double check it by looking at the graph. It's really easy to accidentally put in a number or variable in there incorrectly, especially if you have a lot of variables in your regression. Now that we've done that, we're going to create that second variable, which is going to be called residuals. And residuals means the error between what you predicted and the truth. So we're going to get the actual neuroticism scores, subtract the regression prediction, so that's going to give us our residuals. And so again, we have an extroversion of about 4, so we should have a residual of 27. So let's go find the residuals plot. And we have extroversion of about 4, so our residual around 27. Well, this number, remember, these first two ones are funky, so we know that this is obviously that. But if we look at a more normal data point, extroversion 2.896, so 2.896 should be around, well, they're all going to be around that 0 mark. And they are, for the most part, pretty close to that 0 mark, except for these two bad boys. So now you can do pretty easy things to check, to find the bad residuals. You know that your residuals that have an outlier of more than residual 20 or less than residual 20 are the ones you're looking for. I'm going to try this last part. Don't know if I'll get it right. I always have trouble with this. The last thing we're going to do, not create another variable, we're going to create a filter, and we're going to say that the variable residuals must be let's see, greater than negative 15, and it should be less than positive 15. And if we do that, then what's happened here? We have these residuals. Are they not? What am I doing wrong here? It's between, negative 15 is greater than that. Whoops. I'm a dummy. Let's try that. There we go. There we go. So I got the formula correct. And so what this filter has done is we said we only want the data from the residuals that are between negative 15 and positive 15. We did that because we knew that these guys are outside of that range, so that'll help us ignore them. And so now our data is back to looking normal, back to having no real outlier problems. Yeah, we kind of have a bit of a non-normal residual thing here going on, but that's not a big surprise because our R-square isn't huge. So there you go. That's how you can identify residuals. This is particularly helpful if you have a lot of data. If you know how to do this in Excel, it might be easier there, but this is a pretty useful feature if you're looking into really making sure that your statistical models are very well made and don't have any assumption problems. So hope that helps out a little bit, and I'll see you next time.